Video, we're going to be talking about how to do logarithmic differentiation, otherwise known as log diff. So far we should already know how to differentiate things like x to some value a. If I want to take the derivative of this is our power rule. This is a x to the a minus 1. I also know how to take the derivative of stuff like a raised to the x. That's a to the x times natural log of a. What we don't yet know how to differentiate is when I have a function raised to another function like we have over here. When we have a function raised to another function, we want to use something called logarithmic differentiation. Now you can use logarithmic diff for lots of other examples, but we want to use it for sure when it's a function raised to another function, like we're going to do in our examples today. So let's start with example 1. Notice we can't use our power rule here. I have x raised to another x. So this is a great logarithmic differentiation example. So my first step is I'm going to natural log both sides of the equation. And when I do that, I get natural log of y equals natural log of x raised to the x. And then we're going to use that log rule where I can bring my exponent out front and make it a coefficient. The goal is we are going to get rid of having a function raised to a function. And notice that we've done that in this step. Once you do that, you are going to do implicit differentiation. So let's differentiate both sides with respect to x. I get 1 over y, let's change my color, 1 over y times dy dx equals, on the right side I have a product rule. So I'm going to start by taking the derivative of the first function. Derivative of x is 1, leave natural log of x, and then I have x times derivative of natural log is 1 over x. If you need help with implicit differentiation, I will have that linked in the description of this video. From here, we want to solve for dy dx. So I am going to multiply by y on both sides of the equation. I get natural log of x. Notice over here, x times 1 over x is just 1 times y. Last step is I know that y equals this x to the x, so I'm going to replace y with x to the x. And there is my derivative. Let's do a few more examples. Next one I have is y equals 1 minus 3x raised to the cosine of x. Same thing, notice that this is a function raised to another function. So I'm going to natural log both sides of the equation. And that's going to allow me to bring that cosine of x out front. So I no longer have a function raised to another function. Now I'm going to take the derivative of both sides with respect to x. On the left side, derivative of natural log of y is 1 over y times dy dx. On the right side, I have another product rule. So I'm going to start by taking the derivative of cosine, that's negative sine of x. I'm going to leave my natural log of 1 minus 3x plus leave the cosine of x. Derivative of natural log of 1 minus 3x, it's 1 over 1 minus 3x. But because my 1 minus 3x is inside my natural log, I need to chain rule the 1 minus 3x. Derivative of 1 minus 3x is negative 3. I will have my chain rule video also linked in the description of this video. All right, I'm going to multiply by y on both sides of the equation, and I'm going to simplify a little bit as well. So I get negative sine of x natural log of 1 minus 3x minus, I have 3 cosine of x over 1 minus 3x. And that's all times y. But same thing as before, y equals 1 minus 3x raised to the cosine of x. So instead of y, I'm going to put that. And that is my answer. Let's do a couple more. I have x raised to e to the x. So same thing, we have a function raised to a function. So I'm going to start by taking the natural log of both sides of the equation. I'm going to move that e to the x out front. And now I'm going to take the derivative of both sides of the equation with respect to x. So I get 1 over y dy dx equals, I have a product rule on the right side, derivative of e to the x is e to the x, leave your natural log of x, plus leave your e to the x, take the derivative of natural log. I'm going to multiply by y on both sides, and I'm going to simplify a little bit. And I can put a y here, but I know that y equals x raised to e to the x. So I'm going to put x raised to e to the x. And there's our answer. Number 4, same thing. Notice you have a function to a function. So I'm going to natural log both sides of the equation. And that's going to let me bring my x out front. And it might feel a little weird to have natural log of x. This natural log of x is inside the argument of this other natural log. So we're just going to go with it. I'm going to take the derivative on both sides of the equation with respect to x. I get 1 over y dy dx equals, I have a product rule on the right side, so derivative of x is 1. Leave your natural log of x, plus leave your x, derivative of natural log is 1 over the argument. My argument is natural log of x. Chain rule, I need to now chain rule my natural log of x. I get 1 over x. I'm going to multiply by y and simplify from there. I get natural log of x. Plus, notice you have x times 1 over x, so those make 1. So I have 1 over natural log of x times y, but I know that y is natural log of x raised to the x. So this is going to be natural log of x raised to the x. And that is example 4. We have one last problem. We have our natural log of x raised to the x all over this 2 raised to the 3x plus 1. And I just want to point out that we don't want to start with a quotient rule, because I'm going to get in the middle of my quotient rule and then I'm going to have a problem taking the derivative of natural log of x raised to the x. So I want to make sure I do my logarithmic differentiation first. I'm going to natural log both sides first, and then we'll go from there. So I'm going to natural log both sides of the equation. And then I'm going to use my rule where when I have the natural log of stuff that's divided, that equals the natural log of the numerator minus the natural log of the denominator. I'm going to bring both those exponents out front. And then I'm also going to distribute this natural log of 2. Keep in mind that the natural log of 2 is just a constant. Minus natural log of 2. And then from here, I'm going to take the derivative of both sides of the equation with respect to x. So on the left side, I have my 1 over y dy dx. For my first term on the right side, I do have a product rule. So derivative of x is 1. Leave my natural log of x, plus I have x times 1 over natural log of x. Chain rule the natural log of x. We get times 1 over x. Notice this is a repeat of the previous example. Now I want to take the derivative of the second term. 3 natural log of 2 is a constant times x, so my derivative is just minus 3 natural log of 2. Your last term is a constant, so the derivative of that is 0. I'm going to multiply by y on both sides and simplify. I have natural log of x plus, same thing as before, your x and your 1 over x, multiply to get 1, minus 3 natural log of 2. And I can multiply by y, but I'm going to replace it with my y in terms of x. So I'm going to write my natural log of x raised to the x all over 2 raised to the 3x plus 1. And that is your answer. Thank you for watching this video. We did a few examples of log diff.